My presentation has a rather strong title of How Will Software-Centric Vehicles Affect Future Automotive Supply Chain? Why did we see the emergence of software-centric vehicles? I think you know very well why. Hyundai Motors set the future direction of the future automotives as MECA or MECA. Daimler calls it CASE. MECA stands for Mobility Service, Electrification, Connectivity, and Automation. CASE has shared instead of mobility service. Earlier, as Mr. Haas said during his presentation, in the wake of COVID-19, the concept of sharing has diminished somewhat. So I think Mecha is more fit for the future than Case of Daimler. Such trends in the automotive industry will be realized through software. And in this context, cars will become more and more software-centric. Now, who is leading the development of software-centric vehicles? Actually, it's not who you expect it to be. There are entirely new forms of businesses that are leading software-centric vehicles, like Tesla, that you know so well. Tesla has a culture that originated from IT. And so they are looking at automotives from the perspective of IT device. And so when Tesla entered the auto industry, it became a game changer. Why is Tesla a game changer? Let me explain why. According to Tesla's own expression, it did early commercialization of autonomous vehicles, but of course not fully autonomous, but rather level 2 with ADAS feature. But it does provide the benefits of autonomous driving and the thrill of autonomous driving to the passengers and the drivers. And also, if you think about smartphones, over-the-air software update is very common. Tesla incorporated OTA upgrade to vehicles. When you buy a vehicle, you own it for about 3 years or up to 10 years. And using OTA upgrade, your in-vehicle software will continue to download and upgrade so that you can continue to have renewed user perception even when you are driving the same car for many years. So these two concepts of deep learning-based autonomous driving and OTA software update are not entirely new concepts, but they were new in the automotive industry, and that's why they were so disruptive. So consumers are not so interested in the mechanical engineering aspect of the cars. Consumers began to imbue more value into this software value provided by vehicles. And as vehicles started to provide software value, and due to Tesla's IT-centric vehicle design, you started to see changes in the supply chains that supply complete vehicles. From that point of view, let us take a technical perspective toward vehicles, especially in terms of electronic and electric architecture. Let's look at the inside of the vehicles from that perspective. If you think about cars, they have millions of microcontrollers, and it has a distributed control system with all of these parts. But microprocessors and controllers are beginning to be integrated. So the ultimate objective is as follows. You use your desktop computer in your office or at home to meet your needs. Likewise, you use a small central microcontroller to meet all the needs in your vehicle. However, that central processing has not been reached yet. We do not have a microprocessor that can actually do the job. So at the moment, we still have a distributed control system. If you think about Intel's Mobile Eye, it has video processing using camera data feed, and this sensor has a high computing power to do classification of images, and the upper image can be provided to the central server.
이런 기기를 IT 프로덕트에 익숙한 제조사들은
Manufacturers used to using IT products may feel that this is rather awkward because within a single device, uh, there are millions of different microprocessors and they have different operating systems. So the numerous operating systems are being used in a device. And from Tesla's perspective, which really originated from IT thinking, this was new and awkward. And so that's why they started centralization. So in this case, raw data is sampled and fed back into the central server. And using an exquisite AIT algorithm, the data will be centralized and processed. To do so, you need high computing power microprocessor. Due to these needs, Tesla developed a full system on chip for autonomous driving for in-vehicle computer assistance feature. So Tesla's vehicle became a standardized hardware platform with a standardized operating system, and on top of that, you have various in-vehicle applications. In the automotive sector, this is something that everyone dreamed of for a long time, but was not possible due to various challenges. One of the reasons why is as follows. If you think about the existing software system, you had to apply a lot of changes to it, and also there were safety issues and backward compatibility issue. And that's why this dream was not realized until now. And Tesla became the one that actually made the dream come true. Of course, over the air software update and AI technology to provide consumer innovation, and this year, in the EV market, Tesla has provided a new breakthrough. And traditional complete car makers are making similar efforts. One of the key examples is Mercedes-Benz and NVIDIA's collaboration. Mercedes-Benz and NVIDIA are working together so that NVIDIA's SoC can be used to build a standardized platform. And on top of that, they can actually deploy a standardized operating system. After 2024, new vehicles manufactured by Benz will be built on this platform. And you will be able to see that in 2024. So that will be like the architecture in Tesla cars. And they are going a step further. This is actually referred to as software-defined vehicle. That's what I called software-centric vehicle in the title of this presentation. Such movement is not only visible in Benz, but also in Volkswagen, another German brand. Today, Volkswagen has a traditional system of design and manufacture for mass production of their cars. Therefore, they are supplied subsystems from plural suppliers, and they are integrated to create a complete car. And so the suppliers become black boxes. And there are a lot of microprocessors and operating systems that are not compatible or that are not visible to each other. So such distributed architecture is no longer pursued. Now companies are going for operating platforms and operating systems of platforms that are standardized, just like Benz. In order to create such a future-oriented architecture, you need to actually separate in-vehicle applications from the hardware. And that's why you need to re-engineer vehicles. That's what you call software-hardware decoupling. In order to decouple software-hardware, Well, you need to meet the technological needs, but also this is really changing the landscape of the automotive ecosystem. Suppliers that are core components of the auto industry and the automotive ecosystem have to now find a new way forward. They have to really find a way to survive in this changing landscape. And that's what I would like to talk about in the next part of the presentation. As I said,
기존의 자동차 시장은
if you
전통적인
think about the
자동차 시장은
traditional automotive
차량의
market, the ecosystem looked like a pyramid. At the top of the pyramid, you have OEMs or the completed cars, and then you have part companies or tier one companies that are in close collaboration with OEMs. So tier one companies manufactures and supplies parts to OEMs and subsystems to OEMs. So OEM is supply these subsystems and incorporate them into cars as modules, and also they do sales and marketing of the cars to the end consumers. So of course the OEM's role is important, but tier one companies' role was very important. If you think about the products supplied by tier one companies to OEMs, it's interesting because they are all subsystems or modules. And inside these modules or subsystems, it's basically a black box. They use their own proprietary microprocessors, and they use a lot of different operating systems of their own. And the algorithms or applications that run the subsystems exist within the black box, so you don't know what's actually happening inside the algorithms. So the IP of tier 1 is hidden inside black boxes, which means that tier 1 boxes can create values of their own, and OEMs are paying tier 1 companies for this value. However, if you think about the mobility of the future, software is becoming more and more important, as you know. Therefore, traditional supply chain of the auto industry is changing. Now you have new players that are specialized in softwares that supply software products to the OEMs. So they have joined the ecosystem for the first time. Let me call these new companies software tier 1 companies. If you think about OEMs, they use software supplied by these software companies, and they ask the traditional tier 1 companies to supply products that incorporate this software. This means that the modules that tier 1 companies use to produce are no longer black boxes. Now, in the past, tier 1 companies hid their IP behind black boxes to create value, but they cannot do that anymore. You may think that this sounds like an extreme story, but if you think about the automotive industry at the moment, this is actually happening. OEM may not provide the software to tier 1 companies, but OEM provides specifications of the software to tier 1, which means that a lot of the software ideas have already been transferred to the OEMs. Therefore, the value that tier 1 companies can create from OEMs becomes limited, and therefore tier 1 companies now has challenges in terms of survival. Therefore, this is what it looks like. From the OEM's perspective, in the past, they were supplied products in black boxes, and they were integrated as black boxes. But now they are moving away from this. They want to use standardized hardware, standardized operating systems, and that's what they are demanding tier 1 companies to supply. So that now they are white box products. Of course, there are a lot of benefits from the OEM's perspective because they know what's happening inside. Now they can save the cost for optimization. And also, because software and hardware are both standardized, you now have joint development of software and hardware, which actually curtails the development period, the development duration. And also, you have better recyclability of coding, which enables better innovation. Therefore, from the OEM's perspective, software-centric vehicles are great news. And also, they decouple software and hardware, thereby reaping a lot of benefit. And that means that OEMs and tier 1 companies would compete for software IP. OEMs want to have control over software companies, and tier 1 companies don't want to give away that control over IP. So that's a fight that's going on between OEMs and tier 1 companies. In the traditional supply chain, tier 1 companies and OEMs coexisted with each other as collaborators, and now they have become competitors for survival.
이와 같이 소프트웨어의 등장 그리고
With the emergence of software and a decoupling of software and decoupling, we see a lot of changes in the auto industry, not just in terms of the technology, but in terms of consumer value, as well as the entire supply chain and the ecosystem in itself.
이와 같은 소프트웨어의 변화
Such changes in the automotive industry due to software has to be understood correctly. From tier 1 suppliers' perspective, hardware in automotives and software components in the automotives are both important, and it's about who has control over them. And what's predictable is that at the end of the day, OEMs will take control of the platform. That's the predictable future. And this actually is already what's happening in Tesla. And Volkswagen and Benz are also proceeding to do that. In the mid 2020s, vehicles will become even more software-centric, and applications consisting vehicles will now run on standardized operating systems that are maintained and controlled by the OEMs themselves. One main example is what Volkswagen is doing right now, which is called software-first strategy. If you look at Volkswagen software-first strategy, they actually founded a software company called Car.Software. Car.Software is a subsidiary of Volkswagen. So OEM is now leading the development of software. In this context, tier 1 companies are faced with a difficult situation. So you need to have a correct recognition of where tier 1 suppliers are. When you think about Apple in smartphone industry, that may be comparable to what Tesla is doing in the automotive industry. However, there is still a remaining question, which is who will be the iOS in the automotive industry? So as vehicles become more software-centric, there will be now activities to standardize the operating system, and now the players will have to adapt to this change, and especially tier 1 companies will have to adapt to this changing landscape. As you know, maintaining software platform is a big challenge, and also creating added values on the platform is even more difficult. And this is where global collaboration is needed. If you think about Android or other operating systems, they are basically there thanks to global collaboration, and the same will happen in the automotive industry. And that's why this conference is very meaningful, because it will promote that collaboration. Now I will move on to the conclusion of my presentation. As we move towards software-centric vehicles and technology, the automotive industry will go through complete changes. There will be changes in consumer values, in technologies, and more importantly, there will be changes in the supply chain. In the automotive industry, we need to recognize the growing importance of software so that we can create the values that consumers are looking for using software. To do so, we need to establish the right platform and the right deep learning technology applications, as well as other software technologies. With this, I would like to conclude my presentation. Thank you for your attention.